Welcome to part 9 of having fun with field recording and sound design. I'm here outside, and behind me you see there is a noise protection wall, and behind this wall there is the highway, and I'm going to record the sound of the highway through the vibrations of this wall using contact mics, piezo elements. So as you hopefully see here, there's going to be a film star without knowing it. As you hopefully see here, I've glued the piezo element right to the wall, and I'm really curious how the wind translates through the vibrations of the wall. All right then, back in the studio, I'd like to take to Paul X stretch again and apply it to the recordings. But some further explanations concerning the software's functionality at first. Last time I explained the FFT parameter, so let me go ahead now and talk about the harmonics functionality, which is, I must admit, a little bit tricky to understand. But well, okay. I'd like to start with some phenomenology, therefore some short experiments which may help to understand what's going on when we activate the harmonics section. I've loaded a sound file into Paul X stretch. It contains only one single partial, one simple sine wave of 4200 Hertz. And now let me set the number of harmonics to 10. Let's say the bandwidth to 25. I'm going to talk about bandwidth later. And the bass frequency to 695 Hertz. Let me take my headphones. And what we get is 10 partials, of course, with rather small amplitudes, and one big partial with an emphasized partial at 4224 Hertz. Please notice that 4224 is nearly an integer multiple of 695 Hertz bass frequency. The only frequency found here in the loaded sound file is, as I told you, 4200 Hertz. Let's go ahead. If the bass frequency, the harmonics bass frequency, is far away from these 4200 Hertz, let me go down, then we get only very small, small partials with small amplitudes, low amplitudes, and when we go even further, then we don't hear anything anymore. Let me go a little bit higher, let's say this way, we hear a little bit. But when I increase the number of harmonics, then I'm there where I was before, because the number of harmonics reaches the 4200 Hertz. Well, let me set the number of harmonics now to 25. And go slowly up with the harmonics bass frequency. Oh, number of harmonics 25, of course, not 100. So, and now I go slowly up with the bass frequency. And you see that at certain bass frequencies, even at certain bass frequencies, the partials occur, are getting more emphasized, and we get our big partial at 4224 Hertz, something like that. And this is always when the bass frequency multiplied by an integer number gets at least in the near of 4200 Hertz. All right. So with the range of harmonics, according to the number of harmonic parameters, reaching at least near to the partial which is found, or partials if there are more, found in the loaded sound file, we get sound, we get the emphasized frequencies. But what if the partials or the frequencies here in the sound file are not at all integer multiples of the base frequency? Let me put something. Oh, sorry. It's not. I'm changing the FFT size. I don't want this. Interesting results. I'll be talking about this, what you have seen right now, in a later video as well. So then we get partials, not very loud ones, but we get partials, but none of these partials is 4,200 Hertz or in the near of 4,200 Hertz. All right, if the bandwidth parameter, let's start talking about the bandwidth now. If the bandwidth parameter is high enough, let me increase it, to let the partials generated by Paul X stretch reach at least into the neighborhood of the frequencies which are found here in the sound file, in the loaded sound file, then these partials are emphasized and have a remarkable higher amplitude again. So let me now reduce the bandwidth. And now the emphasis goes down, but now the harmonics, the harmonics, base frequency, and integer multiples of these reach with their individual bandwidth into the near of 4,200 when I increase the bandwidth, and we get what we had before. So it's only Paul X stretch that determines which partials the generated spectrum contains, but the loaded sound file influences which of these partials has higher amplitudes than the others, if there is any with higher amplitudes at all. And because we can set the harmonics base frequency to any value we like to, even to very small ones, the result can get quite far away from what we know as common musical scales. And with that said, we have to talk about the bandwidth parameter now. I've loaded another sound file into the software. It's a sine wave again, only a simple sine wave, but this time it's only a frequency of 262 Hertz. I have set the harmonics base frequency of 100, so 262 Hertz is not an integer multiple of the base frequency here, so the frequency of this 262 Hertz we don't get here in the spectrum. If we don't set the parameters to extreme values, the bandwidth of each generated partial can reach up to 4 halftones, what is 200 cent. So the number here is the number of cents, and each partial is wide. The number, yeah, it's cents, and as you will know, I hope at least, that 100 cent is one full tone, and the distance from, for example, C to D. So let me zoom in here to show what happens when I increase the bandwidth. You see each partial, well, it's not one partial anymore, it's a partial going to and fro across this bandwidth of 2 full tones of 200 cent. Yeah. When I now increase the number, let me go back to 20. No, let it be at 200. 200. When I now increase the number of harmonics here, let me do so. We see something strange happening. Here at a certain point, the lower harmonics simply vanish. And the remaining higher harmonics move. This group here moves higher and higher and higher. All in all, it's quite silent, low amplitudes. Let me go back. And here the software acts reasonable again. And when I now reduce the bandwidth, this effect sets in later with more harmonics more harmonics in the spectrum. And if I reduce the bandwidth even more, this effect doesn't set in at all. So this, let's see, killing of the lower harmonics happens only when the combination of the parameters, number of harmonics and harmonics bandwidth, reaches rather high values. If I want, for some reason ever, both parameters at those high values, let me go up here, at those high values, without Ball X stretch switching into strange mode, I have to reduce the harmonics base frequency to very, very low values, for example, around 3 Hertz. Here we are. Sometimes the values of number of harmonics and harmonics bandwidth are too high even for these low harmonics base frequencies to make Paul X stretch behaving normal again. No, it's okay. And now it's too many. All right then. Let's now watch and listen what Paul X stretch could do with the recordings from the highway. And I'm using in this example now, in the following example, only the parameters number of harmonics, harmonics bandwidth, harmonics base and harmonics base frequency, and FFT size and stretch amount. So only the parameters we have talked about in the last and in this video. Enjoy your day, and don't forget to visit my website, and why not liking this video and sharing it? What about sharing it? Thanks a lot. See you later.